Hi everyone. Thank you so much for joining in today and thank you so much for signing up. It is such an eventful event today as we kickstart our technology series from AAITP Association. So this will be one of the many videos to come in this series. For today, we'll be talking on a subject which is everyone's favorite and most followed by the millennials and the Gen Zs, and that is autonomous vehicles. Yes, it is so fascinating to know vehicles are driven by itself and can have the intelligence of its own. But equally, it's important to be cognizant of the fact how safe are these vehicles. So today's guest speaker, who will be shedding more light on this topic, is an expert in automotive industry. So I would like to welcome Mr. Gulroz Singh into the stream. Hi Gulroz, how are you?
Hi Vivek, I'm doing well. How are you?
Doing well. Thank you so much for joining in, and I welcome you to the AITP Technology Series talk. And you are the first guest for this series.
So privileged to be here. Thank you for inviting me.
Great. So before we start, can you just talk a little bit about yourself, give a little background, where do you come from, what is your expertise?
Sure. So my name is Gulroz Singh, and I'm electrical engineer by profession. I have around 4 years of industrial working experience, and I primarily now work in the semiconductor industry, but I focus more on safety. So I work in the functional safety area. Um, and my focus in the last few years have been around automotive safety, whether that's at the semiconductor level or overall system level. So, so that's really my expertise.
Oh, that's wonderful. So as a general viewer or someone from an engineering background, I always think about autonomous vehicles and I always wonder what technology is primarily being used to drive these innovations. So can you just let us know what about the technologies are used there?
Right. So when we talk about autonomous vehicles, and this has been something that has been going on for a few years now, this is not something that we are seeing as a new phenomena. So the technology has been progressing for a while, for the last few years. And we see that a lot of AI, artificial intelligence, and machine learning techniques have been used or are being used right now in the autonomous vehicles, right? So whether that's for perception, so perceiving the environment, looking at the pedestrians, looking at the other vehicles, or the decision making, everything is driven by software now, and we are seeing less and less hardware in the car and more software. That's what we call a software-defined vehicle in the present era of autonomy.
Okay, thank you. And how does the software engineering, when it comes to a traditional model, differs compared to the automotive industry?
Right. So what we have seen recently is that a lot of artificial intelligence and machine learning become a has been part of the system now and has become a norm. And with that, the challenge is to see how safe that is, right? If we are saying that a driver is not responsible anymore for driving a vehicle and the software is, how safe are we? And the challenge is uh, around safety is not only during the development but also when we deploy the vehicle, right? So during the development, the challenges are pretty simple. The challenges are uh, the software engineering folks that are in the industry, right? We are never taught in terms of engineering how to deal with safety critical systems. When we talk about just software working for, let's say, a website or another consumer electronics product or just a consumer product, let's say another e-commerce website, um, we talk about loss of revenue or loss of productivity, but we never talk about loss of life. Here we are really talking about software affecting people's life, right? And so when we are talking about the verification and validation, the testing uh, of the software, we have to be cognizant about how do we treat this software as really safety critical, right? And with that comes the um, systems engineering methodologies. There are methodologies like model-based systems engineering that have been used in the aerospace and defense industry for for a long time. And there is a reason behind that, because aerospace and defense is, well, it is very safety critical. That needs to be incorporated into the automotive industry as well. And it has been going on for a while now. I would say that a lot of companies commercially have been adopting systems engineering practices that are looking at autonomy as a whole system instead of just a piece of software. Um, and driving that. But then the challenge in the automotive industry is cost sensitiveness, less time to market. So I think the challenge there is adopting practices that deal with safety critical systems in the first place, and not just with a piece of software. Remember, correct software does not mean safe software, right?
Yeah.
A software can be safe only when you have considered everything in the requirements. A correct software is only when your requirements are met. But if you haven't captured the requirements right, it's still not safe, right? So these are some of the common, I would say, challenges in autonomy. And we talk about software and autonomy per se. And I see these challenges going forward as something that the automotive industry is capable of overcoming, but it's not there yet.
Okay, that's good to know. So you talked about many challenges, and there are some segue of taking care of it. Is there any specific set of challenges which is being addressed right now, or how can these challenges be addressed much more aggressively?
Right. So I think the major portion of the challenge is in the perception, right? So in the perception software, that's where it's so difficult to um, understand the complete set of environmental conditions, right? There are conditions that you encounter every 10 kilometers. There are conditions that you encounter every, let's say, a few thousand kilometers, maybe 5K or 10K kilometers. And then there are situations that you encounter only once in a million kilometers, right? So the challenge there is, how do you address those environment conditions in a way that it's not missed. And those less than 2% of conditions are very hard to understand, and it's very hard to robustly test your system against those conditions, right? So that's the number one challenge in the perception software itself, whether that's through LiDAR, radar, or camera, or a combination of all these. It doesn't matter. It really has to be robust enough, right? So the study of, let's say, perception cases, perception edge cases will really help in understanding this. And also this phenomena of the research, right? So in AI and machine learning, we know that it's a hot topic in research. There's so many new things coming out every day, and you can't keep abreast to all those new technologies and techniques that are coming out. But the challenge in automotive industry is not just coming out with techniques, but also robustly testing them sustainably on a commercial vehicle, right? Or before deploying it as a commercial vehicle. So I can have a very good technique in lab where I test it against 200 situations. But when it's really deployed in a commercial vehicle and it faces all the different scenarios, that's when the really the test comes in, right? So before putting your software into someone's hands and asking them to rely for their life on that software, we need to make sure that we're covering all these cases. First, the perception cases, and then, of course, the problem of new research coming out, but with less robustness in terms of software.
Oh, wow, that's really interesting to know. Now that I start thinking more about it, I keep wondering what about the regulations and the standards, because we know traditional vehicles is been around from a very long time. They established enough regulations and standards around it, and each country have their own. So that is being established so well. But now we are talking about autonomous vehicles. So how does it work? Is the same regulation standard work, or is it any different, or how we should be developed in future to make the technology more safer in your view?
That's a good question. I think when we talk about standards and regulations, there are standards around product development. So there have been standards out there for a long time. And by long time, I mean 10 to 12 years. There have been standards like ISO 26262 for functional safety, or the recently UL 4600, or even the SOTIS standard. And these are all standard that you need to keep in mind when you're developing an autonomous vehicle or any kind of vehicle which has electronics and electrical systems. But then the regulation part is still missing, at least in the US, right? So we see European Union coming up with very strict regulations for autonomy, and then we have different states in the US coming up with their own laws and regulations around autonomous vehicles and testing autonomous vehicles. But what we still don't see is a federal regulation in the US, and uh, the regulation authorities keeping pace with the technology basically. So autonomous technology is of course progressing really fast. A lot of companies are trying to develop these and commercially deploy these vehicles, but we don't see the regulations keeping up with the pace of the technology, at least in the US.
Okay, great. Okay. So when it comes to the safety, traditional vehicles have a standard, like it needs to have some X number of airbags, or it needs to pass the grade of crash test, things like that. So autonomous vehicle will have all those plus additional safety features. Is that going to be a mandate of some sort, or whatever we have currently is sort of sufficient for autonomous vehicle to operate?
Well, that's a question that a lot of companies are trying to answer right now. How much is enough? How much is safe, right? And at what point can we say that this is enough and we are ready? There are no regulations right now, at least at the federal level in the US, to say that this is the amount of uh, safety features you need to have, or this is the level of safety you need to attain before you commercially deploy a vehicle. So there of course is lack of data, because this is the new problem. This is a new problem, and then there is lack of regulation in the US, right? Although European Union is coming close to having something regulated, at least in the Europe, but the challenge is how much is enough. That's always a challenge, right? And we're still trying to figure that out.
Okay. I have a couple of fun questions from my side. Um, can we really sleep while autonomous vehicle is driving by itself? Can we sleep peacefully without any trouble?
Right. So the answer to that question is definitely no. You cannot right now with the present technology, but we as humans are very trusting about technology, right? So that's another piece of puzzle and a problem, that we as humans, when we, let's say, drive a vehicle for 600 miles on a road trip, and the vehicle operates really well on the freeway, we can be in a state that we might want to trust the same autonomous technology in the urban areas as well, let's say around a mall, or where there are a lot of pedestrians, right? But that's not something that we should be doing if the autonomous technology is not capable of that, right? But we might be inclined to trust the technology, right? So it's also very important to define what's in the area of the technology and what's not. When is the driver uh, responsible to take over the control of the vehicle? It's very also easy to blame a human eventually, right? So this question comes: who do we blame when there's an accident, right?
Yeah.
You can always blame a human, because the technology, if you blame the technology was also developed by human, right? So either I can say, okay, the driver who was sitting did not take the control and he is responsible for it, or I can say the technology is responsible for it because it malfunctioned, but then there was a software engineer and a validation and testing team sitting behind it, so I can still blame a human. So this blame game can continue, but it's very important to understand, to really be safety oriented in a systems point of view. What are the different hazards that my system can possess, and can have, and how do I address those hazards instead of like having a blame game. Interestingly, if you also read a lot of like accident reports around testing of autonomous vehicles, you'll also see this blame game where the
Yeah.
company would be blaming it on either the driver or the person who eventually installed the autonomous software on the vehicle, or the tester or the verification guy. But when we come out of that zone of blaming, that's when we move towards safety.
Okay. Great. Continuing my fun questions, the second question I have is, can this autonomous vehicle software or the capability can be taken and implemented to all existing vehicles, or only the future ones are getting built will have it? How does that work?
Well, if you look at most vehicles anyway, you'll find some kind of driver assist functions in those vehicles, whether that's lane keeping or emergency brake assist. Those are all driver assist functions. I think that is the need of the hour. We really need those functions to prevent accidents. Really, an accidental situation where you're not able to brake on time, that's where you need the emergency brake or the lane assist, of course, for obvious reasons. Instead of focusing on full autonomy, which I really think it's a distant future, we should be focusing more, or companies should be focusing more on making the driver assist features more robust and investing more in the driver assist features which are presently of use. If you ask, I looked at a consumer report very recently, a survey where people were asked, what do you really think contributes to the safety of a driver while driving a vehicle? They would always say driver assist features would help a lot. Emergency brake or lane keeping would help a lot in saving someone's life instead of full autonomy. When we talk about full autonomy, we are talking about comfort. We are talking about sleeping, as you mentioned. We are talking about watching Netflix, or as Tesla came up with something like a gaming feature in the car. We're talking about comfort when we're talking about full autonomy, but when we're talking about driver assist, we're talking about saving lives. So I think that's where the focus needs to be, instead of really thinking about full autonomy too quickly. That of course the technology will get there at some point, but right now to commercially deploy it, it's still not there.
Okay. So taking any a standard specific car, how many sensors will it have for autonomous driving to happen?
So usually it's not the question of how many sensors, but how are those sensors integrated in the overall system and what sensors am I using, right? So some companies rely only on camera, and some companies rely on camera, LiDAR, radar, and the fusion of that. That's called perception fusion. And it's how good your perception fusion algorithms are uh, will change your system or will affect the overall safety of the system, right? So it's not how many sensors, but it's typically how well those sensors are integrated with the rest of the system.
Okay, great. So one last question is, by when do you think the world will be fully adopting to this um, self-driving autonomous vehicle technology completely?
I think it's hard to put a number on number of years it will take, but I think um, what we still need to focus on is focus on system oriented safety approach, and not on a piece of software. Really the interaction of the software with the rest of the system is the need of the hour. uh, and I think by 2025 to 2026, a lot of the studies are saying that we will move towards full autonomy, right? So hopefully we will get there very soon in 3 to 4 years time, but fingers crossed. And let's hope we're going to get there safely, yeah, instead of losing any precious lives.
Oh, wow, that's not very far. So really excited to see that in full blown proportion. And one thing is, we also asked our members, viewers, attendees if they have any questions, and we had multiple forums, and we got a lot of questions. And there were a couple of questions which were really interesting. And with the interest of time, we have picked up the top two. A
Mhm.
question number one is from Mr. Adam. So he would like to know, what about the cyber security? Can anyone hack the system and have a full control of the vehicle?
Absolutely. As you introduce more software, as you introduce more semiconductors in your car, the surface area of attack increases. You have Bluetooth interfaces, you have Ethernet, you have Wi-Fi. You have so many interfaces that can be uh, exploited by the hackers, by the attackers, and there's always a risk, right? And in fact, in the past, let's say 5 or 6 years, in fact, there have been quite a lot of incidents. in different manufacturer cars, right? So it's about uh, decreasing the surface area, which you cannot really control if you're moving towards a software-defined vehicle. But there are standards like ISO 21434, which is a recently introduced standard in the automotive industry, which focuses on cybersecurity during automotive system development, right? So we need to make sure that we are following those cybersecurity standards, and the companies are not just putting a baked in password. And let's say even just a couple years ago, we see 1234 as a standard password in some of the infotainment
Hmm.
system, let's say, which
Yeah.
can be easily breached, right? So we need to make sure we are not making those rookie mistakes, but then also following standards like ISO 21434 during the development of automotive systems.
Okay. So there is your answer, Mr. Adam. And the second question is from Swati. The question is, in case of any accident, who is responsible since it is driven by an autonomous vehicle?
I think we partially addressed this question during our discussion, but I think that's a question that no one can answer because there's always at the end a human to blame. So when you're saying a computer can handle my vehicle and eventually you can still blame a human, I think we are missing a piece there, right? So that's still a question. That's an open-ended question right now, and a lot of manufacturers still find a way to blame it either on one of the employees who installed the system or tested the system, or directly on the driver. It's very easy to blame the driver when they're dead. The dead can't speak. So it's hard to find a report, a crash report out there, which is not blaming someone, right? A lot of crash reports from different manufacturers would blame someone. I don't want to name the companies. People would know who are following these kind of reports, but it's very disappointing to see the blame game eventually to a human instead of looking at the safety, the overall safety of the system, and thinking, okay, probably this is something that went wrong, and this is where we went wrong, and we can correct this, right? So no, unfortunately, I can't answer that question.
So that's your answer, Swati. Just in case if you get a speeding ticket, chances are you're still paying for it. Uh, all right. I know you're into doing wonderful podcasts. You are sharing knowledge, and you've been really popular among the circuit. If anyone wants to reach out to you, want to know more about it, or want to connect to you, where can they do it?
Well, I haven't been podcasting yet. I do have a podcast in the making, and it's gonna be released very, very soon. But if you want to reach out to me, you can always reach out to me on LinkedIn. My name is Gulroz Singh. We'll put a link down in the description of the video as well, so people can know and reach out. You can also reach out through my website, which is also in the description of the video. We'll make sure that's in there. And yeah, the podcast name is Progress with Purpose Podcast. This is a podcast where I'm going to be talking to a lot of successful professionals, industrial professionals, academic professionals who have gone through different phases in their careers and in their life. And we're going to talk about career transitions, career progression, health and fitness, mental well being, work life balance, and stuff like that. So I feel very lucky to have this opportunity to talk to so many successful people through this podcast. And I hope people who are going to listen to these episodes that I'm recording right now, they'll also feel the same.
Okay, great. And for the viewers, I have attended a couple of webinars which is conducted by Gulroz, and it's amazing. You guys have to attend this. Go ahead, connect with him in the LinkedIn, and attend his podcast and show your love towards him. And do like this video, and if you got something good out of it. And Gulroz, thank you so much for your time. You showed us so many unknown information for us, and we definitely feel a little bit more safer now and have much more hopes towards the autonomous vehicles. So thanks for your time. Anything you want to say before we close this?
No, I think it was a great opportunity to talk to people and talk to people at AITP. I know you're doing great with this organization, so wish you all the best. And thank you
Thank you.
for inviting me. I really feel privileged. Thank you.
Thanks a lot, and there'll be much more similar talks in future. So we'll keep meeting again. So that's being said, thanks everyone. Have a great Friday. Take care.
Thank you. Bye bye.